Hello.
Hello.
Yeah.
Yeah.
Hello.
Hello. Hello.
Yes, sir.
Able to hear me, right?
Yes, sir.
कुछ तो गड़बड़ है क्या हुआ? Why can I hear my own voice 2 times? Nee, Adrit, your screen is still messed up. Chalo, let's start off. So the last thing we did was this one. Perfect. Next thing. Potential energy of center of mass. Let's say there are multiple particles M1, M2, Mn. Heights H1, H2, Hn. H center of mass will be sigma mi, Hi by sigma mi. If you bring it to the left hand side, this will become m into HCOM. Sigma mi Hi. Multiply G on both sides. We get mg HCOM is equal to mi G Hi. So this thing gives you what? So basically this is M1GH1, the potential energy of the first particle, M2GH2, potential of the second particle, and so on. So potential energy of the center of mass is equal to potential energy of the system. Quite a useful thing. So if someone asks you find the potential energy of an extended body, you need not find for each particle, you can just find the center of mass and finish it off. Example. Let's take a solid cone. So if someone asks you the potential energy of this solid cone, will be mg h center of mass. The center of mass of the cone is at a height of h by 4. Mg h by 4. Clear? Check it out. So for this, all these continuous bodies that we studied, right? The potential energy of any of those bodies will be total mass g into the height of the center of mass. Clear? What else is missing? Now, same way, you can't say same thing about the kinetic energy. Let's say kinetic energy of the system need not be equal to kinetic energy of center of mass. Let's say the particle here going with V1, M2 going with V2, and so on till Mn going with Vn. So if you take the kinetic energy of the system, that will be sigma of mi velocity of I square, that is velocity of the ith particle with respect to the ground. So I can write this thing as of sigma mi velocity of the ith particle with respect to the center of mass plus velocity of center of mass with respect to the ground, relative motion, ka square. The velocity of ith particle with respect to ground is velocity of the ith particle with respect to center of mass plus velocity of center of mass with respect to the ground. Expand this, you end up with half sigma mi square vi center of mass square plus half sigma mi v center of mass ground ka square plus sigma mi vi center of mass dot v center of mass ground. Now, if you look at this term here, what is this? When you say mi vi center of mass, so vicm is the velocity, or you can say this is the this is momentum of the particle with respect to center of mass. So the total summation sigma will be total momentum with respect to center of mass. What is the momentum with respect to center of mass? We wrote this last time, remember? 0. Because if you stand on the center of mass frame, you think the center of mass is not moving. So this entire right side term will become 0. So what you left out is half sigma mi is half m v com g square plus sigma half mi velocity of the ith particle with respect to the center of mass square. This can be written as kinetic energy of center of mass, means you treat the center of mass like a particle, find the kinetic energy, plus this is the velocity with respect to the center of mass, so kinetic energy about center of mass. So kinetic energy of a system ka formula is actually this. You can't say kinetic energy of center of mass is equal to kinetic energy of the system. It works for momentum, it works for potential energy, but for kinetic energy, it doesn't work. Simple reason, it works for momentum because it is m into v power 1. It works for potential energy because it is mg h power 1. It doesn't work for kinetic energy because it is half m v square. What is the formula for center of mass? m1, x1, m2, x2, right? As long as the power is 1, center of mass works. If the power changes, it doesn't work. Mathematically, if you think about why it doesn't work, that is the main reason. If the functions are linear, center of mass works. Because it's a v square function, there is no guarantee it will work. Just to give an example, if you have a body here going with you this way, and if you have a body here going with you this way, what is the velocity of center of mass? 0. But what is the kinetic energy? Half mu square 2 times. Did you see? Kinetic energy of the system is not equal to kinetic energy of center of mass. If you look at the kinetic energy of the center of mass, it would be 0. Quite a useful result. We'll be using this again in rotation में a lot. So be careful with this. For potential energy, you can use center of mass. For kinetic energy, you can't. Simple way to remember is any function which is power 1, you can use center of mass. Have a look at this. Derivation is really not that important. Final result is more important. Clear, everyone? Any doubts on this page? Let's see a problem. So we have 3 shapes here. Solid cone, solid sphere, solid cylinder. This height is 2r. This is 2r. Similarly, this is also 2r. This is also 2r and this is also 2r. Find the ratio of potential energy. So the height and the width are same for all, but the shapes are different. Find the ratio of potential energy. Get it? Easy one. Just a substitution there. Okay. For this guy, the center of mass is here. H by 4, which is R by 2. This center of mass is R. This center of mass is also R. So mgh, so rho, volume 1 by 3 pi r square, 2r. This is the mass. G H. It's 2. This is rho 2 by 3 pi r cube g r rho pi r square into r g r. Rho pi r cube g goes off, r also goes off. Rho pi r cube goes off, rho pi r goes off. You're left with 1 by 3 is 2, 2 by 3 is to 1, 1 is to 2 is to 3. Or did I go up somewhere? Because here this 2 and this 2 also will cancel. Hmm. 4 by, this is 4 by 3 by r cube, no? 1 is to 4 is to 3. Right? It is to r, you're right again. Something happened. चलो ठीक है. Clear? Get the volumes mg h central mass. Shit, I got such a good answer. ठीक है, it's wrong. Next one. Easy. Just get the mass, height, and the central mass. So if you don't know central mass results, you're gone. We have a semicircular pipe. In that you have a chain. So when someone gently disturbed it, the chain starts coming out. And this is what happens. The entire chain comes out. If you give a small disturbance, the chain will start moving and the whole chain is out. To find the speed of the chain when it completely comes out of the semicircular pipe. Let's hit this. Hmm. Okay, let's see. Try others. I'll give you a minute. Let's see. Idea is simple here. Here the center of mass is initially at this position, 2r by pi. So when this chain is come down, this would be your center of mass, which will be half of the length of the chain. The length of the chain is pi r, so this is pi r by 2. You can use your entire conservation of energy. Loss of potential is equal to gain in kinetic energy. So this would be mg 2r by pi plus pi r by 2 is equal to half mg square. That's it, you get the answer from there. Yeah. You just have to see where was the initial center of mass, where was the final center of mass, get the difference in height, and that will be equal to the change in kinetic energy. So this is the reason why you need center of mass. Clear, everyone? Any doubts on this? Let's see one more easy one. We have a chain here hanging on a table. Chain of mass m, length L. And here basically one nth, that is L by n part of the chain is hanging. Find the work done to put the hanging chain back on the table. So you want to put this hanging chain back on the table. Easy one. Find work done. Put the hanging part back on the table. Let's get this. Simple thing. If you just look at the hanging part, the center of mass is here, which is L by 2n. Second thing, mass of this part will be m by L into n. So potential energy of the hanging part m by L into L by n. M by n, G L by 2n. mgl by 2n square. Check it out. So that's the potential energy. So when you put it back, you need to give this much energy. This will also equal to the work done. Finally, potential energy is 0. Initially, it is this. So mgl by 2n square. Yeah, mass is m by n. Let's see. Clear? Easy one. We have a bomb of mass m at origin, at rest. It explodes into three pieces of m by 4, m by 4, and m by 2. When m by 4 moves with u along x-axis, another m by 4 moves with u along negative positive y-axis. Find the velocity of m by 2 and the energy released in the explosion. Now slowly we are going from center of mass to momentum. Let's get this. Yeah, Aryan, do it properly. Hmm. So this is initially after explosion. This is how it looks. One m by 4. This is going with u. This is going with u, and this is going with some velocity v bar. So I don't know the velocity of this thing. So the first important thing here is, since explosion has internal forces, it does not affect the center of mass. Momentum is conserved. So initial momentum is equal to final momentum. Initial momentum is 0. Final momentum will be m by 4 u I cap, m by 4 u j cap, m by 2 v bar. So v bar will be minus u by 2 I cap plus j cap. There. And energy released will be, so remember during an explosion you can't conserve energy. Reason being chemical energy is converting into mechanical energy. If you see the unit of energy is what? Potential energy plus kinetic energy. So basically we study only gravitation, spring and kinetic. So final kinetic energy minus initial kinetic energy. Initially it is 0. So half m by 4 u square into 2 times because there are 2 of them. Plus half m by 2. The magnitude is u by root 2 whole square. This would be how much? U square by 4. Yeah, u square by 8. Check it out. Clear? Next one. Any doubts so far? Next one. A particle of mass m is projected with u and theta. At the highest point, it explodes into 2 pieces of m by 2. So one piece retraces the path and comes back to the point of projection. Find the position of the second piece. This is a standard question. Retraces meaning the way it came, it will come back again here. Get this. It's a standard one. I'm sure you must have seen this. Try, I'll give you a minute. There are two ways you can do this. I'll show you both the methods, but the first one is a little lengthy, but it is more powerful. The second one is more easy, but it doesn't work everywhere. So when you project with u and theta with this thing, as you go here, what will be the speed at the highest point? U cos theta. This is just before explosion. So after explosion, this is what happens. This is divided into two pieces, m by 2 and m by 2. So one of them retraces the path. Now think about it. If it came back the same way, shouldn't the velocity also be the same then? So if you come with u cos theta, and if you're going back to the same point, then you should have gone back with u cos theta. So since it retraces the path, and if you think about it logically, the time of flight is the same. So if you want to go back to the same position, you should go back with the same velocity. The time of flight does not depend on the horizontal velocity. Since it retraces the path, it should go back with the same velocity. Same speed. Because it is retracing. So this guy will go with V. Since explosion is internal forces, initial momentum is equal to final momentum. Initial is equal to final. So initial momentum is mu cos theta. This will be minus m by 2 u cos theta. And this will be m by 2 v. So v will be 3u cos theta. You'll understand why this idea is important. Now you think about it logically. If you go with u cos theta, you're having a range of r by 2. If you go with 3u cos theta, how much will you go? 3r by 2, right? Make sense? So the answer is like 2r from the point of projection. Now, why this method is useful? Every time it won't go like this. For example, let's say after projecting, it can happen like this also. One particle goes up with you, then the second particle will have ux and uy. It can happen like this also. In this case, it will go and land somewhere here. So if the particle does not come back, but it flies in some other random direction, then you have to conserve momentum in vertical direction and horizontal direction. Then this question will be completely different. So this is the case if particle goes in some other direction. So then it would be like, the vertical direction, initially momentum is 0. This will be m by 2y is equal to minus m by 2 uy. So uy will be equal to u. And in the horizontal direction would be mu cos theta will be m by 2 ux. The ux will be 2u cos theta. So this question has become like as if there is a building here of height h, and someone projected this particle with ux and uy. And you have to find the range. It becomes a fully kinematics question. This method is actually more powerful. Now, the alternate method which I was talking about, if anyone has done that, you get the answer. But if the particle goes in any other direction, it messes up the whole problem. But have a look at this page. Clear, everyone? Rehan, Paraksh, clear? Maulika? Now, what is the alternate way? Alternate way, since explosion has internal forces, the center of mass will be unaffected, meaning it will continue to go in the same path. Center of mass continues to follow the parabolic path. So basically, after explosion, these two particles will go in such a way the center of mass will continue the same path. So when you project it with u and theta, so this will, I know it will go and land here. R comma 0, R is your range, u square sine 2 theta by g. This is the path of center of mass. And here one of them came back here. So that would be m by 2 at 0 comma 0. The other guy will go somewhere here, m by 2, which is x comma 0. And now you're telling me the center mass of these two is here. So if I apply this formula here, x center of mass will be m by 2 x by m, x is equal to 2r. Easy. This gives you the answer fast. But this works only if both the particles land on the ground at the same time. Can someone tell me why? This gives you answer fast, but it has limitations. If one of the particle reaches the ground first, then the normal reaction on the ground will become an external force, right? One particle will suddenly come to rest. Think like this. As long as both are flying in the air, what happens? What is the accretional center of mass? M by 2 minus g, m by 2 minus g by m, which is minus g, agreed? If one of them lands on the ground, suddenly one term will become 0. What happened to the accretional center of mass? Minus g by 2. Did you observe? The center of mass will feel as if suddenly gravity changed in the middle of the problem. So it won't follow the same parabolic path, it will get messed up. Things will be quite weird. So the most important, right, if you want to use this method, you have to make sure both the particles are landing on the ground at the same time. If anything like this happens, the alternate method will fail. Valid only both the pieces land on the ground at the same time.
So basically, when the y component of the velocity changes, we can't use this method.
Or you can also say both should have same vertical components.
Okay.
As long as they have same time of flight, I don't have a problem. But if the times of flight is not same, if one of them reaches the ground first than the other guy, then when you hit the ground, I'm assuming you will stop. Means if you're stopping, there are external forces on the system at that instant, and that will mess up the whole system. Because the whole story is, since explosion is internal, center of mass should not get affected. Hitting the ground is not internal anymore. I hope everyone has got this logic here. Question is good, but now most of you answered. You see which one you did. If you had used alternate method, you should be clear. This is what will happen. If I use the previous method, you're safe, but that would be a little lengthy. But that is more powerful. Check this out. Here. Clear? Next one. So let's say we have a wedge here of mass 2m. We have a ball here of mass m. All surfaces are smooth. And this is a wedge with a circular track. Quarter circle basically. Radius r. This bottommost point is in. So someone slightly pushed the ball and the ball started rolling down. Now, as the ball is coming down, understand it will push the wedge also backward. The wedge is also moving back now here. Find the speed, find the velocities, and the normal reaction when the ball reaches point A. This would be a good question, right? Same question we'll see in rotation. That will be even better than this. That would be a proper advanced paragraph. Normal reaction at point A. Let's get this. Now, listen. This is important. Now, as we go ahead, right, now things will start getting more and more complex. There are just too many things coming up, one after another will keep popping up. The reason why most people start finding it weird is because they don't develop a, what do you call, a kind of an algorithm kind of thing. It is not only about studies, anything in life. When you keep learning, at one point, what will happen? There are just too many things. If you don't organize them properly and if you don't learn them in a proper format, now, I'm not saying the format will work, but eventually that will start messing up. You'll start getting confused what the hell to do. Simple thing. Let's say tomorrow you opened up a small, what do you call it, a biryani shop. If you're just opening one shop, things can go up as that. Kuch problem nahi, you can manage. But let's say tomorrow you open 3 branches. Somehow you can still branches and you can still manage. But once you go all India and you have 1,000 branches, the game is different. So every time you open a branch, you can't keep going, running there and telling them. You have to give them an instructions. So for example, let's say in your area, you want to open a McDonald's franchisee. There are certain list of conditions you have to satisfy before they allow you to open a McDonald's shop. Right. So they have some agreements. So everything is formalized. So they have a proper thing. And that is the reason if you see it, you go to any McDonald's shop, you'll find the French fries will look similar. They want consistency. Getting it the burger or something, anything like, that whatever product that you're getting, they make sure they're getting it supplied, same thing to every restaurant and maintain it. The reason it works so well is because when things become big, you need to formalize things. You need to have a process. Ever seen any movie or something, plane mein kuch ho gaya problem? First thing they do, they take out, what you call, there is a manual. For every damn problem that can happen in a plane, there's a manual. So all the issues they could think of or that happened so far in the aviation history are recorded in their manual. A simple thing, aeroplane is going and there is a volcano blasting. Uska bhi manual mein likha hoga. If there's a volcano blasting nearby and an aeroplane is going, what are you supposed to do? There is a snowstorm, what are you supposed to do? Crow came and fell into the engine, what are you supposed to do? Everything, maximum thing they can think of, everything is there in the manual. So same way when you're learning physics also, now if you think about it, initially it was only kinematics. So theek tha, 3 equations, then NLM, free body, theek tha. Then it was like work per energy, conservation. You said, okay, now things are getting more. Now, naya conservation of linear momentum. So when you keep doing, right? So one time now I realized this actually. I was solving problems. My friends used to find it difficult, but I was quite comfortable. When I went and thought about it, what I realized was when I see a problem, right, it strikes me. When you say it strikes, meaning there is something I'm doing which my friend is not doing. Actually, this is how I improved my maths also. Whatever I did for physics, it was natural to me, but maths was not natural to me. So remember this thing, not a complete thing, but this is what, when I do a problem, this is what I do. Again, this thing works almost 95, 98% of the times. There are times when this also fails, but maximum cases will get covered. So when you see a problem, let's say if you have a question, works preferably for mechanics, but then again, you can even use it for later on electromagnetism also. Whenever you see a question, right, in physics, technically we have only two weapons. That's the best part. Unlike maths, right, where you can approach a problem in 10 different ways, physics, you can approach the problem only two different ways. One, either you can go with your force equations and torque equations, that is your laws of motion. Let me say force and torque equations. Torque we have not done, that will be the next chapter. Or you can go with conservations. Luckily, any problem, right, most of the time they will classify into one of them. Now, how do you know which one it is? You have to look at the words in the question. You'll hear words like this, find normal reaction. Think about it. Normal reaction, first time, where did you hear? In NLM. What do we do in NLM? We draw FBDs. Getting it? Find normal reaction. Listen to everyone. I know you guys are doing. Shut up and listen for some time. Focus on this. Typing all wrong answers. Listen. Finding tensions. Right? Finding normal reactions. Ali, focus. You guys think I'm doing a joke or something here? Focus. And then later you say, sir, when I see a problem, I don't get a single idea. So find normal reaction, find tension, find time, find acceleration. You'll hear these kind of words. Observe, you must have seen all these words in NLM, friction, these kind of chapters. In all these chapters, what you did was always you started with an FBD. When to use conservations? If you see here, the words would be like, find max velocity. Getting it? Find velocity at that position. Right? Or you can say they find final velocity. Max compression, max height. Getting it? It is always about, if you look at these words in this thing, right? The question is always about finding something after some point. I mean, they don't care what is happening in the middle. They're always bothered about final. So here the emphasis, right? The word emphasis more on final. Here emphasis is on final state. So that is the thing you should know. You have to use conservation. Then once you do that, the second important thing, you have to know how to draw an FBD. If you don't know how to draw FBD, you're gone. In conservations, you have to draw the final diagram, the final state and the initial state. Meaning you have to draw the diagram with velocities, position, whatever it is. So this is where you need to have proper visualization. If you can't visualize properly, the question won't go ahead. Most of you, right, what you do when you see a question, you keep thinking, "Arey, kaun sa formula lagam, kaun sa formula lagam." Arey, forget about the formula, na. Think about how does the final situation look like. Most of you can't visualize the situation. That is where you guys get stuck actually. Once you know how the final situation looks, problem solving becomes kind of easy. Then once you get that FBD, then what you do? Draw forces and everything. Calculate forces, calculate torques. Assign constant equations. The standard process. Assign accelerations, use constraints, and solve. If you can draw a proper FBOD, 50% of the problem gets over. In this case, you have three options here. You can conserve energy, you can conserve linear momentum, you can conserve angular momentum. Angular momentum we didn't do. That's the next chapter. That's it. These are the three conservations we have. Now you need to figure out which one to conserve. When can you conserve energy? If work done by external is 0. So after drawing the final diagram, check out, is there any external forces doing work? Yes, then don't conserve energy. No, conserve energy. When can you conserve linear momentum? F external is 0. When can you conserve angular momentum? Torque is 0. So once you got that, solve. That's it. Simple plan. There's not much, but the main thing is figuring out which side should I go. Sometimes you have to use both the things in combination. For example, look at this thing. What did I ask you? Find the velocities when you reach point A. Means you are interested to find the velocity when the ball reaches here. Means I don't care what is happening in the middle. You're only bothered about something which is happening finally. Doesn't it look like what? Conservations. Now see, which conservation I have to use, wo idea nahi hai mujhe. But this much idea I'm getting that I have to use conservations. Then you also said find normal reaction at point A. Means what should I do? I should draw an FBD at point A. You're getting it? So listening to that words, right? These are the key words. When you know these words, you'll know which way to approach. So let's see how to do this thing. So one thing, I try to find the velocities, and I'm sure what to do. I have to use conservation.
Ball or the wedge?
Both. Find both.
Oh, so I sent you the answer of wedge.
चलेगा देखते हैं. So initially, this is the diagram. This is initial state. This is your final state. Now, when I say final state, it is just not about drawing the diagram. Figure out the stuff. This will go with V1. Do you really think this will also go with V1? This will go with V2. Masses are different. There's no guarantee they'll be same. Then, since horizontal forces are 0, there are vertical forces here. So one thing is clear, I have to conserve. Now, which one to conserve is the thing. First thing, horizontal forces are 0. So I can conserve horizontal momentum. Therefore, horizontal momentum will be how much? Initial momentum is equal to final momentum. Initially, it is 0. mv1 minus 2 mv2, v1 is 2v2. As suspected, both the speeds are not same. Second thing, here there is no friction. Gravity is fine. There's nothing else here. The work done by external forces is 0. Therefore, initial energy is equal to final energy. That's it. Once you know you have to conserve energy, check for all the three possibilities. Can I conserve energy, momentum, or angular momentum? You have limited choices in physics, so you can check out everything. Initial energy will be mgr. The ball is at a height. So basically, you're choosing this as a reference line for potential energy. Finally, when the ball comes out, potential energy is 0. The velocities will be half mv1 square plus half 2 mv2 square. So mgr, substitute the velocity v2 there, and this would be three mv2 square. So we get v2 is equal to root gr by 3. And once you got that, v1 will be 2 times root gr by 3. Okay, that's how you get velocities. This might look obvious, but as things go on, you need to keep developing this algo. You should know. Later on, we'll see some problems which does not work on this algo also, meaning there's one set of problems which don't work this way. They neither go with force equation, they neither go with conservations. Those are some deadly ones. We'll see that later. Now, that you will know it doesn't work because you have an algo. If you don't have a proper format for anything, then you will think everything is new. So the most important thing, right? I don't want you to think like physics mein every question is new problem. Every problem 60 to 70% will be something in common. That 20-30% is new. Once you start thinking that way, you'll be able to handle a lot of problems. That is the reason why, most people, if you see in top 5,000, whoever gets a rank in top 5,000, almost 90% of them, their favorite subject is physics. Because once you start developing that kind of ability to see a question and figure out what to do, it saves a lot of time. You just need to put the relevant things and just get the answer. Because you have a format to think. Anything. You are trying to teach someone how to dance, or you're trying to teach someone music, there is a format you have to teach them. You teach them every day one song without giving a proper instructions and all. After 1 month, they really don't know what they learned. Kabhi hua, you solve a question, you got the answer, but you're not confident you'll be able to do it again afterwards. Or sometimes you got the answer, but you don't know how the hell you got an idea to do that. That is the most dangerous one. Getting an answer without knowing how you got it is very bad. Because that will lead to overconfidence. So, lagega ho jayega somehow, you're leaving everything to luck. And then when one day, when the questions actually come, you can't figure out what went wrong and it goes for a toss. Happens a lot, in surgeries. If a patient dies, they're actually not worried about the patient. They actually worry like what the hell went wrong in the operation theater. They launch a full-scale investigation. They check out, did the doctor do any wrong, or is the treatment anything wrong? So they actually check what is going wrong rather than people died. People dying is common, big deal. That to hai. Without killing few people, you can't become a great doctor. So that is how life is. Who is a doctor with experience? He just killed a lot of people during training. So that is the reason you don't put them in surgery on day one. You keep them beside a senior surgeon for 1-2 years and you make them watch. And then you start them with small operations. They still goof up, but there is someone to supervise. So works out. You are there anyway under anesthesia. How do you know? The second part. Yeah, seriously. Normally that is how it goes. Why do we say IIT Bombay is better? We say we have good facilities, good placements and all. You know what's a good hospital? A good hospital is one with a lot of dead bodies. The more dead bodies a hospital has, the better facilities it has, and more practicals the students can do. That's it. That is the reason Mumbai hospitals are so famous. You have a lot of patients and a lot of dead bodies. And it looks weird, but that's how you decide for them. The second part of the question, find normal reactions. So how do you do that? Since you asked for normal reaction, there's no doubt. If I ask for force, there is no point in conservations generally. Draw an FBD. This is important. Listen. What are the forces? Normal reaction, mg. It is going in a circle. Can someone tell me what is the centripetal acceleration? The ball is going with v1. What is the centripetal acceleration?
V1 square by 1.
Nah. Centripetal acceleration is what? We have done this. Nay, that is not right, Monica. A centripetal is what? v1 plus v2 whole square by r. In the centripetal acceleration formula, when you write v square by r, v is the relative velocity with respect to the center. Think about it. Who thinks it is going in a circle? The person who's standing on the center, right? This guy thinks it is going in a circle. The person on the ground will see him going in some weird path. But this guy himself is going with v2, right? The ball himself is going with v1. So with respect to the center, the velocity is actually v1 plus v2, v relative. So when you say v relative, this is the velocity with respect to that moving center. Till now, you never had a problem because the centers never moved till now. Because this guy, he sees the particle going in a circle. If you try to see it from the ground, it won't be a circle, it will be some weird path. So the observer on the center, so you have to take the velocity with respect to him. sees the ball going in a circle. So A centripetal is V. So here V relative is V1 plus V2. Therefore, A centripetal will be V1 plus V2 whole square by R. Be careful. It's not V square by R. V is not the velocity in the ground frame. This you would goof up. So this would be N minus mg is equal to M into A centripetal. So normal reaction would be mg V1 plus V2 square by R. Check it out. In centripetal acceleration, V is the velocity with respect to the center. It's not in the ground frame. Didn't we do this in circular motion? We wrote a statement like this, if you remember. You guys forgot. There, 14th question C. Same thing. Page 47, circular motion. Check it out. I taught you that for this problem here. Clear with this? This would be a good advanced question. If you see, energy conservation, momentum conservation, loss of motion, circular motion, 4 chapters. Clear? Next one. Similar equation. We have a ring here of mass 2m. This is tied to a ball here of mass m. The string has length L. So the ring can slide freely on. The ring can slide on the horizontal rod. Connected to a ball with a string L. With the string of length L. Gravity is there. So if you leave this, what will happen? How do you think will happen? If you leave this, this is what will happen. The ring will be here. The ball will come here. If you see here, the tension is pulling this ring and the tension is pulling this guy. So after some time, the ring will come here and the ball comes here. Isn't this how the motion goes? The ring is moving to the left. The ball is coming towards the right. They're moving towards each other and finally they become vertical like this. Find the speeds and the tension at the lowest point. When I say speeds, I want both of them. Advancement, I'll ask you find tension directly. Find the speeds and the tension in the string at the lowest position. I hope the diagram is clear. When you leave the ball will start falling down and the string will start pulling the ring. So the motion would kind of look like this. The ring is going left and right and the ball is oscillating. So when this ball comes to the lowest position, find the speeds and the tension in the string. Anyone not clear with the question, please ask. Now again, this and the previous question are quite similar. The problem kya hai na, when most people try to see the question in terms of diagram rather than in terms of concepts. If you see in terms of diagram, it looks like totally something else. But once you start solving, you'll realize this and the previous one are kind of similar. Try, you got 2-3 minutes.
So,
Arjun.
Why do you not consider gravity as an external force while conserving momentum?
Then if you want to do gravity as an external force, then stop writing gravitational potential energy. No, you can't say I'll have gravitational potential energy also. I'll also take work done by gravity also. Because work done by gravity is only negative of potential energy, if you remember the derivation.
Yeah.
There, I'll show you that thing. You have already taken care of that by introducing the term there. In this derivation here, what you did, this work done by this internal conservative forces is there.
Oh, okay,
That became minus delta U, that shifted that way. So that is already included. So the moment you use the word, I'm going to use gravitational potential energy, that mg is already taken care of. But if you insist on that, then stop using gravitational potential energy. That becomes more complex. So it is there. Think of like this. Whenever you say mg is there, why are you not using it? The potential energy is already included in that. It is taken care of. That way. Everyone should try. Answers, everyone. Find the speeds and the tension. Okay. Get the tension. That might be Rotarian. Dekhna padega, I don't know. Try. 2 more minutes. Show you. Step 1 is figuring out, should I use force equations or conservations? It is clear, it is conservations. How do you know? Look at this word. Find the tension at the lowest position. Means you are bothered about finding something at some position. Means you're not interested what is happening in the middle. You're getting it? That's what I'm saying. When you read the question, there are words. These words should trigger you. This word means this. This word means this. If you don't develop that ability, you will start finding every question will look like a monster going ahead. See, अभी तक कितना chapters हुआ? Vectors, kinematics, NLM, friction, circular, work power, energy, ray optics, centrum of our 7 to 8 chapters. But around 6 months ke baad, or by the time next year when you finish it off, you'll have almost 22 chapters in hand. You will not be able to do this thing. Fluid mechanics, everything will pop up from everywhere, and you'll think, what the hell? That is the reason most people start getting overwhelmed, because they're not organizing whatever they're studying in a proper way. So more than studying, right, it is also organizing how you study, what you study will matter a lot. Because when you have so much content to do, you will forget something. And if you don't organize, you will not understand what you forgot. Problem dekha? It's not, forgetting is not a problem. Forgetting that what you forgot, and if you don't realize what you forgot, you will never revise, and that will always keep an uncertainty in the mind. It's very important that you know what you will forget. So when you're organized, you will understand what you forgot, because you will see there's a huge gap in that. Just like my wife ka packing. When we go somewhere, right, I have to pack my stuff. My wife packs her own things. I make a checklist on a paper before going, 1-2 days before. 2 days before I start writing on a paper. I will take this thing, okay, 3 shots, 4 pants, deodorant, phone charger, every damn thing that I remember, I keep writing. After writing everything, right, I leave it for a day. Next day, right, as the day progresses, I keep remembering, अरे वो भी लेके जाना था, वो book भी लेके जाना था. You know, mom last time told to bring some documents, वो भी लेके जाना था. So 1-2 days, I just keep writing. The page gets filled up. I just start the packing 1-2 hours before, and everything gets done. I don't miss anything. On the other hand, my wife does something else. She starts packing 1 day before. She's putting everything in the bag, and after she realizes, अरे ये भी लेके जाना है. End में when we get into the cab, she realizes she forgot something. It is a common story every time. Kidding? If you don't organize stuff, things will start. Every time she forgets something, kuch na kuch. So initially I used to get irritated. Now you get used to it. So that's what happens. So you should know that is how the theme is. So you need to organize your stuff properly. So step 1. This is 2M. This is M. Initially the whole system is at rest. This guy becomes like this. This becomes like this. This guy goes with V2 and this guy goes with V1. Horizontally, there are no forces, so horizontal momentum is conserved. P initial is equal to P final. Now, just look at the equations. Forget about the diagram. Look at the equations. Initial momentum 0. Final momentum is mv1 minus 2mv2. v1 is equal to 2v2. Isn't the equation same? That's what I said. Both the problems are identical. I just gave a ring and a thread. There I gave a wedge. And here energy is conserved. So you can accelerate loss in P is equal to gain in kinetic energy. Could have done in the previous one also. Loss in PE is equal to gain in kinetic energy. So this length was L. So this would fall mg L is equal to half m v1 square plus half 2m v2 square. Isn't this the equation same? They are identical problems. सिर्फ L का place में R था. Take v1 and substitute there. You get mgl. If you substitute there, this will be 3/2 m v2 square. V will be root over 2gl by 3. And v1 will be 2 times root 2gl by 3. Check. Same thing. I think 2 नहीं आएगा. Done. Next thing, you want to find tension. What should you do? Draw FBD. Again, the same thing. Who thinks it is going in a circle? The person on the ring will think it is going in a circle. Forces, tension, mg, centripetal acceleration, which is v1 plus v2 whole square by L. No difference in the problem. Everything is same. This is what I said. If you had realized what to do, you would have realized it is the exact same problem. So tension is equal to mg plus m into v1 plus v2 square by L. Check. Substitute the values and you'll get an answer.
So we consider this thing to be slack initially.
Meaning it is just tight. It is horizontal and it is tight.
We won't consider it to be a horizontal force.
नहीं है ना, हाँ, initially horizontal force है ही नहीं. So once you leave it, what will happen? It will try to fall like this, and then the string will become tight and it will start pulling automatically.
Okay, got it.
If it is loose, they will draw like this.
Okay.
Clear with this, everyone? Did you observe it as the same problem? That's what I'm saying. Don't think problems are different. It's the exact same problem, just the wordings are different. Go, take a break. Come back by 7:03. Any doubts? Anything so far you want to ask, you can ask. Or let's go take a break, come back by 7:03. Any
Sir,
doubts?
Can
Any
you
questions?
show today's first slide?
Today ka first slide. I don't know what is that. I think this one.
Yes. Thank you, sir.
Any doubts?
So-
Anything? Rehan.
Sir, in the last class, usma that double integration wala question, I couldn't solve it at home. Could you please explain again?
Which part you didn't understand? Where is that? बोलो ना, which part you didn't understand?
Sir, actually the entire question only.
Why? What were you doing in the class?
I was doing, but sir, when I tried to solve it again, then I didn't understand only like.
Recording देखने चाहिए था ना? There was a recording in the group also. Didn't open it?
No, sir.
You should have just opened it and 2 minutes देखना चाहिए था. And if you still didn't understand, I was there. You didn't put enough effort. See, what you do here? You take a small element here. This part you understood. Taking
Yes,
a small
sir.
element. Then dm का part is clear.
Yeah.
Sigma into dx dy will be length into breadth. So that will give you sigma into area. तो mass आ गया.
Yes, sir.
Now, maybe you got confused because I tried to do everything in one go. What if, imagine, just if you try to only x ka coordinate, it will be x dm by integral dm. This is fine.
Yes, sir.
So then x will be x only. What will be dm? Dm will be this guy.
Yeah.
So this will be I cap, na?
Yeah.
Then this will be y dm by integral dm. That will be j cap, na?
Yeah.
So I did both at the same time. Xi plus yj into this will be the dm ka term.
Okay, sir.
Now, because there is a c na, dx, dy, there are two differentials. You have to put double differential.
Yes, sir.
So how do you know you have to put double differentials of dx, dy? For example, if there is a dx, dy, and dz, you'll keep triple differentials.
Okay, sir.
So and then what we did, x and y are two independent terms, right? When I expanded this, dekho, I gave all the x ka terms. So I multiplied this thing to this thing to this. And then see what happened here. So for the I cap ka term, what is there? Sigma naught, x,
Yes, sir.
x square,
Huh.
dx and y dy.
Okay, sir. Understood.
Dikha? And then same thing I did with y also. X dx hoga y square dy.
Yes, sir.
And then when I opened it, I gave one integral to y and one integral to x.
Yes, sir.
I think once you got this, it is simply
Yes,
single
sir.
integrals, na?
So then I understood.
I think you just saw double integrals and got confused. Nay, it is a little confusing though. एक काम करते हैं. Let's see after the break. I'll do one problem.
Okay, sir.
But देख लो, फिर भी if you're still confused, तो ask me.
No, sir. I understood. In that double integration only, I got confused.
I know that you have to give that integral to separate x and y. Na, वो idea maybe that should have been that might have stuck confused you. होता है. This is new. Anything else? Anyone?
No, sir.
Chalo, take a break. I'll be back by 7:03. It's a cuboid. Cube nahi hai, cuboid with sides A, B, C. The density is given by rho naught x y square z cube. Find center of mass. Triple integration. Since you're finding double integration tough, we'll do triple. So double will look easy. What do you think? So just get me the steps. रेहान अभी देखते क्लियर होना चाहिए. Please, Rehan, see he's not there. Anyone wants to blame, you can blame him for creating triple integration. Come on, Rehan, triple integration. Let's do it. This Arjun was all, saying all bad things about you. That because of you, we have to do triple integration and all. He's spreading rumors. Chalo, how to do? If you guys start doing Erido, right, you'll observe ये double and triple integration बहुत आएगा उसमें. Erido book is pretty good. Concepts are good, but more than that, mathematically, Darge goes pretty deep. Russian books are normally general like that. They put a lot of max. And I hope everyone has seen, right? Erido ko maine bheja tha, list of questions and all. So seriously, if we start doing, I think maybe weekly do like 5 to 10 questions. You have to finish the book by next December. So don't treat it like kuch assignment jaisa treat mat karo usko. Just keep solving for fun. Maybe 5-6 questions per week. If you think that way, it is fun. Because even if you don't get a question, you'll not get tense. Like you'll not be in a hurry to find a solution. Take time. Just to give an example, right? I still remember when I was in 11th and 12th, there was a question which I didn't get almost for 7-8 months. I never bothered also. Meaning I used to think about it when I used to get 1-2 minutes and then I used to leave it. And one day out of nowhere, I just got an idea and I solved it. Because there is no pressure. Ye chhod do. The best part was this. After becoming a teacher, right, there was one question which was in some JEE paper. I didn't get it for a year. And I didn't bother to ask anyone. I said like, yeah, we'll not ask, we'll see. After 2 years, I didn't get it. Finally, I got irritated. I said, yeah, abhi check karte kya hai problem. I checked it online. The question was deleted because it was wrong. That's the sad part. कुछ नहीं कर सकते अभी. That question was given bonus that year. It took me 2 years to figure out the question was wrong. And I was hitting my head, why the hell it is not striking? Because this time Google and all were not there. Anything you have to figure out on your own. Try it. I'll give another 2 minutes, then I'll show you. Did everyone get the volume element? What will be the volume element? dV will be dx, dy, dz. You take a small cuboid of with the dx, dy, dz. Mass will be rho naught x y square z cube dx, dy, dz. That will be the mass of that small cuboid. Sigma. Arjun, is that the final answer? God, coordinates रे xi cap by j cap z k cap ना. ये क्या था? मास है क्या? What did you type? है मास कैसा होगा? X Y Z A B C Y. How can you get X Y and A B C all in one single term? Got the element here? Now look at this. Since it is confusing, what we will do 2 by 3, 3 by 4, 4 by 5. I think so. Hanika, you might be right, I guess. Check karte hain ek bar. Now, since we are getting We'll not do all at the same time. Let's do one at a time, okay? First, let's find x coordinate. So this x coordinate would be integral. Formula kya tha normally? Integral x dm by integral dm. So this gives you the x coordinate. So this guy will be x coordinate rho naught triple integral, because there are 3 dx dy dz. X, y, we'll keep all x's together. Rho लिख लेते हैं एक बार अच्छे से. X rho naught x dx y square dy z cube dz by triple integral rho naught x dx y square dy z cube dz. Now when I separate this out, give one integral. Let's push that rho naught outside, constant. Give one integral to x dx, that will be x square dx. Give one integral to y square dy. Give one integral to z cube dz. Same thing you do, push out rho naught here. This will be integral x dx, integral y square dy, integral z cube dz. Limits will go from 0 to a, 0 to b, 0 to c, 0 to a, 0 to b, and 0 to c. If you solve this, you end up with 2a by 3. Because देखो ना, this full term will cancel ना. This full term and this full term will cancel. Only the x term will be left out. So this gives you an interesting idea actually. And you can do the same thing with y coordinate also. So if you do the same stuff here, I will leave the working to you. You can prove it. Anika, you got it right then. So y coordinate will be 3 by 4b. Z center mass will be कितना आया था? 4 by 5c. Right, Anusha.
Then why aren't we doing all of them together again?
Because I can do it. People got scared because of that only by doing everything. You want to do everything, you can. Bas itna difference aayega na. This will be I cap ka term, then it will be j cap ka term and k cap ka term. You could have done that.
Yes.
Now I just wanted to show one term so that you actually, get it. The reason why this looked more scary was because I did everything in one go. Isn't it? This looked scary because I did everything in one go. But when I did only one term, you could actually see how it worked, right? That's it. Aur kuch nahi hota. Exam mein I would have done everything together. Clear? Understood triple integration. It's not really out of the world. Now you can do this question even better. If this comes in the exam, you will observe something here. You can make this cube I don't know whether you noticed it or not. See, these are the things, when I keep saying, it is not always about solving a problem. Did you notice something? I'll give you a minute. Question ho gaya, answer aa gaya, acha hai. But did you notice something? Anything that you notice, you can tell me. I'll show you something, then I'll ask you the same thing. Oh, theek hai, Adrit, that is right, but there is something even better. See that? Okay. See this? Okay. You're seeing? See this? See this? Matlab x square ka center of mass is 3l by 4. Similarly here, if you observe, y square ka center of mass is 3b by 4. Whatever happens in x, y and z don't care. Whatever happens in y, x and z don't care. All three are independent of each other. This problem can be split into 3 rods. You can make this one rod. You can make this one rod. You can make this one rod. Where this rod ka density, you can take lambda is equal to lambda naught x Here rho is what? Rho naught x y square z cube. You can treat this rod lambda is equal to lambda naught y square. You can treat this rod lambda is equal to lambda naught z cube. So if it is proportional to x, the center of mass will be at 2a by 3. For this rod of height b, this is x is equal to a and x is equal to 0. This center of mass will be y will be 3b by 4. And for this center of mass, z will be how much you got? 4c by z. 4c by 5. You can treat them as 3 independent rods, find the centromes for each rod, and then just get xyz coordinate. If you think about it, the reason if you see a diagram mein na, these terms got cancelled, right? Literally, what left is only x na. Doesn't this just look like x ka center of mass? Does it really matter what function you take for y and z? हर बार ये दोनों terms cancel हो जाएगा. So what's left is only x का term. So when you're finding x center of mass, what matters is only x. When you're finding y center of mass, what matters is only y. When you find z center of mass, what matters is only z. But this is an observation. But this is what you need to figure out. It's not about just solving the question and leaving it off. You start seeing questions like this and start observing and try to figure out new ways and new things in this. Your confidence on subject will skyrocket, right? You guys' subject will be at a different level. But problem kya ho raha hai na? We are obsessed with, we are just trying to do spoon feed, try so many different models and remember every other model so that exam mein something new comes, we don't know what to do. The fun of figuring out a question and solving is gone. You ask, any person who is in the top ranks, right? Ask them, how do you feel when there's an exam? Or how do you feel in the exam? What they say, they're having fun. And seriously, meaning maza aata hai when you're solving and you're getting questions, right? And when you're not getting question, you feel like, okay, I'm getting a chance to learn something. They're not really bothered about marks. You have to be bothered about marks for what? Final exam. You can't be bothered for marks for every exam. If you ask me, right, PACE people, right, you guys should be bothered only about major test ka marks. The remaining exams, you should learn as much as possible to absorb from the exam. But anyways, triple integration is clear. Complete mathematical. You can see from the mathematics, we can figure out something like this also. Meaning you could have done the same thing with the plate also, right? So if they ask you this question in the exam, the JEE people will expect you to think this way. They won't expect you to do the full math. But anyway, still if triple integration comes, it works. Clear? Let's see, get back to momentum. This also do a proper advanced paragraph question. Top view. Mass M, mass M, and mass M. 3 masses there. Let's call this A, B, and C. So this length of the string is L. This length of the string is also L. This center one is given speed U. So this whole setup is placed on a smooth horizontal floor. I'm sure you must have seen this question in the PACE booklet. That is not the actual question though. There is something even better. So if you kick it like this, what will happen? B will go ahead. This is what it would look like, isn't it? After some time, B will go like this. A and C will become like this. And after some time, they'll become straight like this. Now, technically, I should not be telling you this. You should figure out on your own, but I hope you got the diagram at least. Think of like this. Now, if you stretch your hands like this, and if you go forward, can you see both your hands go backward? You stretch your hands both horizontal legs, and if you go forward, both of your hands will go back. It's like Naruto running. People who know Naruto, you will understand. Putting your hands both behind and you run. So something of that sort. So here, what is happening? The A and C are coming towards each other. So the standard question is this. Find the velocities of A, B, C just before A and C collide. Find velocities of A, B, C just before A and C collide. So if B is given initial velocity U. This is not constant. Someone kicked it with you. मतलब B का speed भी decrease होगा. And if you think about it, tensions are pulling this way. So B actually slows down. A and C will actually speed up. Find velocities of A, B, C just before A and C collide. Find the
So
tension in the string.
Yes, well.
Are? Come again?
Is there gravity?
No, top view and a smooth horizontal floor.
Oh, acha, sir.
Find tension in the string. The second part is actual question, right? The moment I add the second part, it becomes an advanced question. Find the tension in the string just before A and C collide. Sure, get this. Get the first part. You get 2 minutes for the first part. Then second part, we'll think about it. No, Arjun, that's wrong. What is the step 1? The final diagram. 1 more minute. Try. Everyone should give it a try. It's okay if you don't get an answer. But if there are 5 steps and if you can figure out 2 to 3 steps, I think you're doing a pretty good job. See. No one got the speeds. I thought you guys were let it. See.
2 minutes almost.
2 minutes nahi milega. You'll get another 30 seconds. Do. Anyway, by the time I draw diagram and all, you'll have time. The M&M, this thing is going with you. This was at rest. This was at rest. Then this is the before diagram. So final diagram would look like this. B would be here. A and C would be like this. Now understand, they will have same velocity in the upward direction, VC. Let's call it V common basically. This will be VC, this will be VC. Why? Because the string is tight, isn't it? If the velocity is not same, the string will become loose. Velocity along the string has to be same. But that also, other than that, VA will also have a horizontal velocity, isn't it? You're forgetting A and C are also coming towards each other. So A and C will have two components, one vertical and one horizontal. That's your final diagram. B will have one velocity vertical component, whereas A and C will have two components. I hope you figured that part out. And then if you figured this thing, you're done. Momentum is conserved. Vertical direction में momentum P initial is P final. Initial momentum is mu. Final is 3 mvc. Vc is u by 3. Work done by external force is 0. Energy is conserved. Initial energy is equal to final energy. Initially only B is going, and this guy would be half m vc square plus vx square into 2 times, because there are 2 of them, plus half m vc square. This is for A and C, and this is for B. This is the energy of A and C. Anyone confused with the steps, please ask. And then take VC and substitute here. That will be half m u square 3 by 2 mvc square plus mvx square. Vc is u by 3, u by 9, 1 by 3, half minus 1 by 3 mu square, 1 by 3. I hope I'm right. Vx is equal to u by 3. There. So A and C ka speeds are Vc upward and Vx horizontal. Take your steps. This is the first part. Now find tension in the string. Try. You got another minute. Okay. You guys found magnitudes. क्या? ठीक है. U by magnitude कितना होगा? U by 9 plus U by 3. 2U by 3, right? Speeds will be 2U by 3. This week test was there on NLM, friction, circular, work power energy, everything full combo. Huh? You have a deadline till Friday night 11, so make sure to give it.
So kinematics is also there.
Everything. Kinematics is also there. Optics nahi hai, I think. Full mechanics only.
Achha.
Only mechanics. From kinematics to work power energy. How do you find tension? That's a pretty good one. Huh? You will be learning a new, what should I say? New concept, you can say. I won't say concept also. Problem where yeah. I'll show you. Try. Concepts you know, but application is something else. This is what I keep saying. If you just keep reading notes and books, you will. If you keep reading books, right, you will never learn that. Let's see what is this. Try. I'll give you a minute more. This is what I did. This question is actually from Pace booklet. Find velocities. Itna tak tha. We just added little more and said find tension. Suddenly the question becomes something else. This is what I keep saying. You need not do different things. Just take one thing and you can play around. Let's try to go from our format. What did I ask you? Find tension. So what should I use? Free body diagrams. There is the first thing. So draw a free body diagram. So the first problem here is if you draw the FBD of B, there is a tension. There is a tension. That means B itself is decelerating actually. So 2 times tension is mass into acceleration of B. This is what most people forget. Second thing, when you draw the FBD of C, is A going in a circle? With respect to whom? Ground frame में circle में नहीं जा रहा था वो. It is going in a circle with respect to B. If you stand on B, you think A is going in a circle, but normally on the ground, it is going pretty weird actually. If you ask me, it is like going straight also, it is going like this also. So B thinks C is going in A is going in a circle. And remember, B is a non-inertial frame. So the observer on B himself has an acceleration, it's a non-inertial frame. So we have to apply pseudo force. So if you look at the forces, you have tension. There is no mg here. What is the pseudo force? Mass of the body, acceleration of the observer in the opposite direction. There will be m into AB. This is the pseudo force. Since B is non-inertial. And now B thinks it is going in a circle. So you'll also have centripetal acceleration. Actually, you can use centrifugal force also. That means you'll get double pseudo forces. One pseudo force because of centrifugal, one pseudo force because the observer is moving. And we have AC, this will be Vx square by L. So we get from here tension plus MAB is equal to mass into, I'll write this as A centripetal because you will think AC again. A centripetal. M into A centripetal. But what is MAB? 3T. This will be M. Vx square. What is Vx? U by root 3. Mu square by 3L. Tension is equal to Mu square by 9L. You know what most people do? They will write tension is equal to centrifugal force. They'll write T is equal to Mx square by L. This is what most people write for tension. But what they're forgetting is the reason you think it is going in a circle is because you're observing from B. But if you start observing from B, B himself is accelerating, so you have to apply pseudo force. So you know this concept, right? That if you're standing on an accelerating frame, आपको pseudo force लगाना है. That concept, you know. But it won't strike. No matter how much you have read that statement, it won't strike in a problem. Check it out. It's a pretty good one. So this idea is important. So if you ask me today, what is the most important thing you learned? Centers are moving. Particle is going in a circle, but the center where it is moving, the center is actually moving. The previous question we saw the center was moving. So we took relative velocity. In this case, the center itself is accelerating, so you have to take a pseudo force. We didn't do these kind of problems in circular motion. We couldn't do. There we didn't have enough subject, enough knowledge. So here, the first time you're seeing things, where the centers are moving and accelerating. So the whole thing gets goofed up. Please have a look at this. Anyone not convinced with this, not clear, please ask.
So can
Ah,
we
good.
write like F equal to dp by dt only for the particle that's moving horizontally?
F is equal to F, what again?
F equal to dp by dt. And
how do you calculate P? How do you calculate P?
P, only of the top particle, the initial momentum will be mu. And at the moment we calculated the V comment will be.
Arjun, you said dp by dt.
Yeah.
Why are you writing delta P?
Okay.
And second thing, do you know the time?
Oh, yeah.
In how much time does A and C collide?
Okay.
Won't be able to solve. That is finding time is actually mathematically not possible. वो भी try किया मैंने, नहीं होता है. You get an integral which is not integrable. You'll get something of this sort. D theta by integral root sine theta. And this is not integrable. Looks very innocent, but you can't integrate this. Clear with this? All got the problem? Let's see one more.
This is 1 minute.
Yeah.
So if the length of the string was not constant, we wouldn't be able to tell that it's moving in a circle, right?
नहीं, we can't. इसलिए एन सी का मास सेम होना चाहिए.
Okay.
Next thing.
The main thing in this problem was figuring out that B is going to decelerate, right?
हाँ.
Okay.
Most people forget that part. They simply write T is equal to mv square by r.
Hmm.
They think the only force acting on A is the tension. That is a catch. They forget about B. Most of us forget about B. Top view. We have a mass m here. We have a string here. This is also mass m. So in the middle, you have a loose string of length 12. But whereas the distance between the balls is L. This is placed on a smooth horizontal floor. Top view, there is no gravity. Then what you did, someone kicked this with speed u. एक काम करते हैं, let's make it 2m. That is even more fun. Okay, they kicked that upper ball with speed u. Find the velocities just after the string becomes tight. Describe the motion of the balls. Describe the motion, matlab you just have to say like how it looks, what happens. Find tension in the string after it becomes tight. Let's get this. First get the velocities. Just to give you an idea what happens, see, as this ball starts going forward, string kabhi bhi loose hai na? The 2m ball will not move until the string becomes tight.
फिर horizontally उसका length √3 वो आ जाएगा.
Yeah. I hope the question was clear. You have two balls with a string between them is 2L, but you kept them only at a distance L, so the string is loose. And you hit the ball on the upper one with speed u. Find the velocities just after the string becomes tight. Describe the motion after it becomes tight and tension in the string. Basically, everything is just after it becomes tight. Get this. How do we find that? U by 5, U root 3 by 5. Okay. This is a situation. So when this guy reaches here, this length is 12. So this angle is 30 degree. So this angle is also 30 degree. So if you look at this velocity u here, it has two components, u cos 30 and u sin 30. Now why this is important? Because when the string becomes tight, how is the forces? Tension, right? The only force which is actually responsible for changing velocities is tension. Therefore, velocities will change only along the string. Do you agree with that? Since the forces are along the tension, or you can say velocity components perpendicular to tension cannot change. Components of velocity perpendicular to the string do not change because force is perpendicular. Only velocities along the string will change. That is the first idea you need to know.
Velocity along the string should be same, na? नहीं तो string टूट जाएगी.
I meant to say velocities after it becomes tight, right? मतलब maybe I didn't put it in a proper words. The string change.
तो ये तो velocities along string change तो नहीं हो सकता ना.
No, I'm not saying m and 2m will have different velocities. They can change, na, but they should be same at every point of time. Where I'm saying it is different.
अच्छा, at every
Velocities
point
along the
of
string.
time. हाँ, okay, okay.
हाँ, at every point they will be same. मतलब if this guy is VC, this guy will be VC.
हाँ,
That way. And this component will be U sin 30 only. That cannot change. Everyone agrees with that?
Yes, sir.
So along the string will be same. That is different story here. So velocity along the string is same. Then you're done. So conserve momentum along the string. That would be m into u cos 30 is equal to 3m vc. So v is equal to u by 3 cos 30. There, that's your velocity. U by 2 root 3. So that means the m will have a velocity vc and u sin 30, whereas 2m will have a velocity along the string. Now what? Describe the motion and find the tension in the string. 2 more minutes. अभी try करो क्या करना है. How does this motion occur and circular about why circular about 2m mass? 2m is what? Great or what? You're a racist. Who means whoever is more massive, you think that person is better. I think we should call you massist because you discriminate them based on the amount of mass. mu square by 8L. देखना पड़ेगा. Was not expecting that. हो सकता है, I guess. Tell me one thing. All this nonsense is happening. Everyone is going randomly, everything. But there is one thing. One guy is going with a constant velocity. Who is that? There is someone going with constant velocity. All this chaos. All this nonsense. There's one guy who's going with constant velocity. Center of mass. Because the tension is internal forces. Center of mass doesn't care what is happening with anyone. It will continue to do whatever it is doing from the beginning. So if you try to look at the diagram M and 2M, where is the center of mass? It will be closer to this guy, somewhere here. And what is the velocity of center of mass? U by 3. Mu by total mass. So this center of mass will continue to go in a straight line, independent of what anyone does. So when the string becomes straight, this is how the diagram looks. This is M. This is 2M. This would be your center of mass. This length will be 2L by 3. This length will be 4L by 3. Isn't that how the center of mass divides in the ratio 2:1? So this will go with whatever is the velocity we see. This is how the motion looks. So the center of mass will think 2L by 3 is going in a circle of radius 2L by 3. And this guy will think M is going in another circle of radius 4L by 3. Able to see how they'll go? The center of mass will keep going in a straight line. And these two particles will rotate about the center of mass. Isn't that the concept of center of mass in the beginning we decided? About a system when you take, isn't that the whole point of center of mass story actually? When you throw something into there or when something is moving, the center of mass will continue to do whatever it does normally and everything else will rotate about it. And I think we did this example with दिया था मैंने कहीं पे. Somewhere I gave. I didn't give, I guess. ठीक है, same thing anyways. Got the catch? Great. How do you find omega? So what are the components here? So this guy is V U sine 30. How do you find omega? Do you remember the formula? If you have two velocities, how to find omega? The relative velocity perpendicular to the line joining them by distance between them. That's how you find omega for two particles. Where is that? This one. If you have two particles having velocities, you take the velocity perpendicular to this thing by distance between them. Isn't that how you find omega? Circular motion page 5. Check it out. So omega will be V relative perpendicular to the string by distance between them. That way you'll get omega pretty fast. So luckily, if you see, right, there's only U sine 30 and the distance between them is 2L. So omega is actually U by 4L. Now be careful. When you want to find tension, you always have to do it from the center of mass. So the center of mass will think this particle M is going in a circle where the force is tension. I can write the centrifugal force or centripetal acceleration AC will be how much? U sine 30 whole square by radius. So tension will be M into U sine 30. That is U by 2 whole square, and radius is how much? 4L by 3. So this would be 3 mu square by 16L. Check. You could have taken the 2M also, you'll get the same answer. In case of 2M, the radius will be smaller, na? 2L by 3. So tension is M omega square L. Wait, why did I do this? No, I did wrong. Wait.
फिर इसमें relative वाला क्यों नहीं?
Omega square L R actually.
हाँ,
Omega square R I have to use. If I don't do that, I have to use relative only. So
yes.
tension is M into AC. That's what I was thinking. Why the hell did I find omega then? This guy would be U by 4L whole square by 4L by 3. Mu square by 12L. Check your answer.
Could you go to the previous page once?
Please check it out, everyone. Yeah. Any doubts on this? So do check it out. It's a pretty good one. If you see there again, momentum conservation, circular motion, every damn thing is there. This is what I keep saying. You should know how the system will look after the motion happens. So that point will go in a line and everything else will rotate about it. Clear? Last time I was saying something, no? Remember this? No, I think we didn't do.
Ask if it
Still didn't do stability of systems, no? Look at this thing.
people ask if it's glued, if there's steel rods. A lot of people really don't understand that it's just balanced.
These mind-bending rock formations are held together with nothing but gravity. Rock balancing art predates the Bible and can be found across the globe. Michael Grab is one of the best balancers around, and his creations have turned him into an internet phenomenon.
The structure that probably got me noticed first internationally was kind of this orb structure that I made. And it's just hundreds of little rocks kind of balanced on a really tiny one at the bottom. One of
मजा
my
आता है ना इसमें
favorite
सब बना के लास्ट में तोड़ने में
mission at
एंड इसका देखना जॉब प्रोफाइल देखा
Rock
माइकल ग्रैब रॉक बैलेंस दैट्स अ जॉब टू हैव रे वो भी एक टैलेंट है so that is one and I'm sure you must have seen this thing बैलेंसिंग बोर्ड Amazon में मिल जाएगा 500 रुपीस में do anything on it doesn't fall. It's even more fun.
This video I'm gonna show you another cool. It's extreme. The hammer and put it through the rubber bands, and I'm probably gonna do it this way here because it's just easier to hold this way. And I'm gonna put it this way like this. Check this out. The hammer is hanging. And I can
That is not the fun part.
put
The fun part
this
is this.
on the edge, like right here. Now check this out. It still
Still balances.
Yeah, it hangs without no problems. Look at this. And obviously nothing under here and over here. Let's look at this closer. Look at this.
You can shift it even close.
And that's where you can enjoy this on here on the roof.
So what's happening exactly here? Fidget spinner, nahi. Fidget spinner is a different concept. So what's happening here is, this is actually based on rotation, but we'll have a little idea here. Stability of systems. Just imagine if you take something like this, and if I leave it like, do you think it will remain at rest? This will fall off, right? The reason being, the center of mass mg will be somewhere here. And if you look at here, normal reaction will be somewhere here. So this produces a torque, the rotation. So this thing topples. This thing rotates. So the reason here is, since n and mg are not along the same line, they create rotation. So if you want to keep something at rest, there's a condition you have to satisfy. But same thing, if I do like this, don't you think this can be at rest? Possible, right? This can be addressed. By changing the mass or something, I can adjust. The difference will be, this will have a center of mass here, this will have a center of mass here. When you take these two, maybe the center of mass of the system will be here, and that mg is actually passing through this. So the condition is this. For a system to be stable, the weight vector should pass through the base in contact, or should pass through the area within the base. Pass within the area in contact. So that's the main condition there. As long as it passes within the area in contact, you can keep it in stable equilibrium. So if you look at the diagram there, let me show you. This thing, we used to have it at home when I was in school. I was so fascinated by it, I broke it one day. And what I found inside is, there's a metal piece here, there's a metal here, and there's a metal piece here. Such that the center of mass will be somewhere here for this bird. So this thing always passes through this base. That is the reason, you do whatever you want, nothing happens. There. This is the thing which I brought from Amazon. It is the same thing. You'll get it for 600 rupees. It works. What if we keep that in an inverted V and N MG? If N are not MG on the same line, it goes off. But this concept is clear. This is how that rock balancer is working actually. He is making sure that MG is always passing through the area in contact. The main idea is that. So you guys try this question. We will be discussing that in the next class. We have planks. I'm sure you did something like this in school. Ever tried with this thing? Notebooks, you kept one notebook on top of another and you tried to push them. So like this. So we have 4 identical planks on a 4 planks of length L are placed on a table as shown. So I wanted to arrange them in such a way. So this point is the A. This is X. So arrange them in such a way X is maximum. Find the max value of X, meaning you can just keep pushing them until no one falls. Find max value of X if the blocks don't fall over. If the planks don't fall or planks don't topple. Got what I'm asking? If you keep it too far, the diagram would look like this. They would become something of this sort. I don't want this to happen. So I don't want them to fall. So what is the maximum you can push them and keep it? Try this. This we'll discuss in the next class. It's a good one. Acha result you can remember. Okay, so next class when we catch up, we'll continue from here. We'll do more problems on this.
So the dimensions
Alright.
of the table aren't needed.
No, you don't need.
Okay.
सिर्फ plan का length पता है. Dive table का you don't need.
Okay.
This one.
Nice, such a homework question.
No. Someone asked. Aryan, clear na? Chalo, then with that we'll wrap up for the day. So make sure to try this and come. We have done almost 27 problems. Do try all of them once more. Especially those integration problems, right? Try to do them on your own once more. How to take element, how to integrate and all that stuff. That's important.